All right, we're going to, at this point, do a quick review of factoring quadratics. We've done some of these before, but we want to do a quick review on these before we actually start using those factors to solve a quadratic. We're going to start off with factoring when a is equal to 1. And we're going to do a whole bunch of these very quickly just to make sure that we have practiced every possible type of quadratic we might run into. First of all, x squared plus 9x plus 20. If we want to factor this, this is the simplest type of quadratic to factor, and a here is equal to 1. When that's the case, we simply look for factors of c, which in this case is 20, which add up to b, which in this case is 9. So we want things that multiply to give me 20 and add to give me 9. And we could make the entire list of factors of 20, but it should be fairly obvious that we are looking for the numbers 4 and 5, because 4 times 5 is equal to 20. 4 plus 5 is equal to 9. So since I know that we are talking about at a equal to 1, I can simply take those two factors and factor this quadratic as x plus 4 times x plus 5. And I'm done. I have factored my quadratic. If I want to check that, the easiest way to do that is to simply FOIL my binomials back out. So first gives me x squared, outer gives me 5x, inner gives me 4x, and last gives me plus 20. If I add like terms here, I get x squared plus 9x plus 20, and I'm right back where I started, so I know I have correctly factored my quadratic. Still do another one very quickly just to make sure we have the hang of this. X squared plus 14x minus 72. Here's where knowing your multiplication tables comes in very handy. We start looking for factors of negative 72 that add up to positive 14. Now notice this c value is negative, and yet the center term is positive. So I know one of my factors is going to be positive, one of them is going to be negative, otherwise it would not multiply and give me a negative number. And I know the larger number is going to be positive because it's going to add up to a positive number. Those factors in this case turn out to be negative 4 and 18. If you have trouble with that, just start dividing 72 by various numbers until you find the set that adds up to 14. So this factors as x minus 4, x plus 18. And I'm done with my factors for that particular quadratic. All right, let's look at one that is just a tiny bit different, one where I'm looking at a value where a is equal to 1, but in this case I don't have that center b term. If it helps you in the initial stages of learning this, you can rewrite that quadratic as x squared plus 0x minus 64 to remind yourself what we're trying to do in this quadratic is find factors of negative 64 which sum to 0. We want them to add up to 0. And that means the factors are going to have to be the same number, but one of them positive and one of them negative. That's going to be 8 and negative 8 in this case. So this factors as x plus 8 times x minus 8. And I'm done with that kind of a problem. So if it makes it easier for you, put that 0x term in the middle in order to factor that type of quadratic. All right, what if a is not equal to 1? Well, we have several possibilities here. The first one being, what happens when a is equal to negative 1? If that's all you have at the beginning of your polynomial, of your quadratic, for example, negative x squared plus 13x minus 12, then the easiest thing to do is to say, okay, that -1 is a common factor, and we need to factor out the common factor first. So if we have a common factor, it always factors out before we start our problem, and that includes that that common factor is a -1. So let's take the -1 out of our quadratic. That leaves us with x squared minus 13x plus 12. We're factoring that negative out of all of the terms. So now we have the same kind of polynomial we had a minute ago. We're looking for factors of 12 which sum to -13. Well, that's going to be -12 and -1. So -1 times x minus 12 times x minus 1 is the factored form of this quadratic. Please make sure that you are writing this negative out in front. Now, it is acceptable to just write negative x minus 12, x minus 1, but you do have to make sure that the negative occurs out here somewhere in front of this polynomial. It is a common factor. Let's try one more of these just for a little practice. Negative x squared plus 14x plus 32. Same kind of problem. My a is equal to -1. So we're going to treat that as a common factor and factor it to the front. So -1 times, and if we divide -1 out of all three terms, we get x squared minus 14x minus 32. So we're looking for factors of -32 that add up to -14. So if you think about that for a minute, you'll discover that that's -16 and 2. -16 times 2 is -32. -16 plus 2 is -14. So if we write this in factored form, we have our initial common factor of -1 times x minus 16 times x plus 2. And our quadratic is now in factored form. And we'll look at in the next lesson exactly what we use that for. Why do we care that it's in factored form? And we'll look at that in the next lesson. All right, well, let's look at another common factor. What if we have a quadratic where a is not 1, a is not -1, but there is a common factor somewhere in the quadratic? Well, we got a couple of possibilities on what could happen there. First of all, I could have a quadratic that looks like this: 6n squared plus 9n. Notice what I'm missing on the end of this. I don't have that c term here. Therefore, I'm going to look at these two terms, and the first question I'm going to ask is there anything that will factor out of both of these? Well, 6 and 9, what number goes into both of those? That's 3. Well, is there anything else? Well, yes. I've got n squared and I've got n. So n is also a common factor. So my greatest common factor for that quadratic is 3n. Now, I need to know, what am I going to multiply that by? Well, 6n squared divided by 3n is 2n. Or another way to look at that is, what do I need to multiply this 3n by in order to get 6n squared? And that's 2n. What do I need to multiply 3n by in order to get 9n? Or what's 9n with the common factor of 3n divided out? And that answer is 3. So this factors as 3n times 2n plus 3. The fact that this is not a binomial is not a problem. I only had two terms here. If I wanted to check this, I would just distribute the 3n back into my binomial here and discover that I was right back where I started. All right, let's do another one, and let's do one that's actually got the trinomial. What if I have 4x squared plus 20x minus 56? In this case, it looks very much like the ones we've been doing, but my a value is not 1. My a value is 4. So the first question I would generally ask here is there a common factor in this? Is there something that comes out of all three terms? And it does have to divide evenly into all three of these. In this case, that number is 4. So I divide out my common factor. 4x squared divided by 4, that leaves me with x squared. 20x divided by 4, that leaves me with 5x, and negative 56 divided by 4 leaves me with negative 14. So I've divided out my common factor. Well, once I've done that, this should look very familiar to you. We're looking here at a quadratic with a equal to 1. So I'm going to look for factors of negative 14 that add up to 5. And those factors are 7 and negative 2. It means that this factors as 4 times x plus 7 times x minus 2. Be careful, this common factor, don't drop that. It has to be written here as part of the factored form of my quadratic. Alright, well, what if a is not 1, but there's not a common factor? These are probably the most challenging ones to factor, but there's a nice, neat process that allows us to do that. The absolute value of a is not equal to 1. A is not 1 and it's not negative 1. And there is no common factor. Or maybe there was a common factor, but I took it out and I've still got a not equal to 1. So how about this one? 2x squared plus 11x plus 12. Well, when I learned to do this in school, I learned to do this with trial and error. But there's a very nice process that will always get you the right answer in this type of a factoring problem. So you don't have to trial and error until you find something that works out. We simply take the A and the C and we find their product. We multiply them together. So in this case, that means we're going to multiply 2 times 12, and that's going to give me 24. That's something you're just going to have to memorize. I multiply A times C, that gives me 24. I now look for factors of 24 that add up to this center term, 11. Now, before we were looking for factors of C that added up to 11. This time I'm looking for this product, AC, factors of it that add up to B. And it should be kind of obvious if you know your multiplication tables that that is 8 and 3. So what do we do with that? I still need to make sure I end up with this 2x squared first term here. So the process we use to do that is we rewrite our quadratic as 2x squared plus 8x plus 3x plus 12. Now notice what I've done here. I have rewritten these two center terms. I've taken this 11x and split it into two pieces, 8x and 3x. So now I look at the first two terms and I ask myself the question, what is the common factor in those two terms? And the common factor in those two terms is 2x. So when I divide 2x out of those two terms, I'm left with x plus 4. Now we do the same thing with the second two terms. The common factor in 3x and 12. And the common factor in 3x and 12 is 3. So I write plus 3 and divide 3 out of those two terms. That leaves me with x plus 4. Now notice I have the same thing in both sets of parentheses. If I don't have the same thing in both sets of parentheses, I did something wrong. I need to go back and look at my problem. But I have the same thing in both sets of parentheses, so I rewrite this as what's in the parentheses, x plus 4, times what's not in the parentheses, 2x plus 3. And I have factored a polynomial where the absolute value of a was not equal to 1, and I didn't have a common factor that let me change it so that a was equal to 1. Let's do one more just for practice before we quit here. Let's do 4x squared minus 4x minus 3. No common factor. Nothing will go into 4 and 3 evenly. So I need to use this new process. So I'm going to multiply 4 times negative 3. And 4 times negative 3 is negative 12. So now I need to look for factors of negative 12 that add up to negative 4. Well, what can I multiply to get negative 12? Well, I could do 1 and negative 12. I could do 3 and negative 4. I could do 4 and negative 3. But none of those add up to this negative 4. The pair that adds up to negative 4 is negative 6 and 2. So I want to rewrite my quadratic, splitting this negative 4x into two pieces. 4x squared minus 6x plus 2x minus 3. And then we're going to use the same process we used a minute ago. Look at the first two terms. What's common? I'm looking at 4x squared minus 6x. Common factor here is 2x. When I divide the 2x out here, I'm left with 2x. When I divide 2x out here, I'm left with minus 3. Then I move to the last two terms, 2x minus 3. There's nothing common there. But I need to be able to end up with two binomial factors. If there's nothing common in these last two terms, I'm going to say plus 1 and leave the 2x minus 3 inside my parentheses. And I can do that because 1 times 2x is 2x, 1 times negative 3 is negative 3. I haven't changed the value here. So now I have two binomials. What's inside the parentheses, 2x minus 3 times what's not in the parentheses, 2x plus 1. So these processes should allow us to factor any quadratic into two binomials if it is factorable. And we will look in the next lesson at why we care about that, what we do with those two factors in a quadratic.